So this video is for P5. We're going to be taking a look at rational expressions this time. There are a lot of examples that I put in this slideshow, so please make sure that you're taking good notes and that you're doing those examples right along with me. If you want to, it'd be a good idea to copy the example down when it pops up, give it a try, and then start back the video and see if you and I end up matching with that. Okay? The first thing that we're going to talk about is finding a domain of an expression. What they're referring to there is identifying any values of x that make the statement undefined. Well, the things that do that are ending up with, like number 1 says, can't have a 0 in the denominator. All right, so we have to make that statement of what x cannot be to avoid getting that 0 denominator. 2, you cannot have a negative number under a radical sign. Okay, so with our next slide, I've got 3 examples that have us playing with this. Example letter A, this one there are no exclusions. You can put any number you want in there, you can cube it, you can multiply it then by 4, add 3, and you will have a real number answer. So this domain is simply stated as all real numbers. Okay, you can put anything you want to in for x. Now, letter B does have a radical sign. So again, you have to make sure that we stay on the positives when we're talking about square roots. So negative 7 makes the square root of 0, and that's still okay. But any negative number smaller than negative 7 is going to give us a negative root. So we have to state that a couple of different ways. You could say x has to be greater than or equal to negative 7. Or you could write it out in words where you could state all values of x such that x is greater than or equal to negative 7. I like the symbols, it's faster. C, the x is alone in the denominator, so the only thing truly that's not going to work here, your domain would be all real numbers, but x cannot equal 0 itself. That's the only thing that would make it a 0 in the denominator. Okay, so domain works not too bad. Take a look at some more examples that are in the book, the ones that are done out for you. Again, I'm kind of choosing for the slides the checkpoint ones. And again, if you want further explanation on any checkpoint ones, you can go for another explanation by going on to that Larson.com site. And it does a nice job of listing out some more stuff. Next slide. All right, page 42 starts us with simplifying rational expressions, and we're going to be doing a million varieties of all of this stuff. They're going to give us an involved expression. We're going to be using a lot of our factoring skills from our previous section, and we're going to cancel everything that we can, and then what we're left with is our reduced rational expression. So taking a look at the one I have up on the board. Okay, see if you can't factor some things out and do some canceling, and find what would be left over after you eliminate some stuff. Okay, and then when you're ready, turn this back on. So I'm going to go ahead and pull 4 out of my numerator, and the bottom is a trinomial. That would factor into x minus 6 and x plus 3. Again, if you're having a little bit of trouble with that, you can always list the factors of negative 18 off to the side. And that way it makes it a little bit easier to see what's going to give you that negative 3x in the middle. So for example, we know that 1 and 18, 2 and 9, and 3 and 6 make 18. Those two are 3 apart, so that gives me a pretty good idea of which numbers I'm going to have to work with. Then it's just down to figuring out where the negatives and positives go. All right, so back to the problem. Look at what our factors have shown us. We have an x plus 3 on top and bottom, so they can cancel, and your answer is just what's left. A 4 on top, x minus 6 on the bottom. Now, the book is going to then work with that domain stuff, and you'll see a comma, and x cannot equal a 6 for this one. Okay, 6 would make that denominator a 0, and we can't let that happen. All right, I'm not going to write that in every time, but that's an example of what you do see in the textbook, and that's why they're saying that. Next one, we have a little bit bigger trinomial. Nothing bad yet. Okay, so this expression, let's take a look at factoring it. So 3x and x have to be the way that we break the 3x squared in front. And we've got a negative 2 in the back, and we want a negative 1 in the middle. So if I put positive 2 here and negative 1 here, I'm going to get my negative 3x and my plus 2x, which give me that negative 1 in the center that I want. Okay, now the bottom. The bottom is not written in the right order. Okay, notice that it's not in standard form, so I'm going to do that first. So I'm just going to rearrange it so it's in standard form. The other thing that's customary to do is to get rid of that negative in your lead coefficient. So I'm just going to pull out a negative 1. And now I'm ready to factor. So I've got a negative 1 still, x plus 5, x minus 1. They give me my negative 5 in the back, and they will also give me that 4x, that positive 4x in the center. Now look for canceling. Both top and bottom have an x minus 1. So that negative, I'm just going to throw it in front of my whole thing. Top, 3x plus 2. Bottom, x plus 5. And we're done. Okay, moving on. In this next expression, we're going to multiply together two fractions. We're multiplying together two rational expressions. With multiplication, remember, we have that cancel step. So let's go ahead and factor all of our pieces and see if any of them can eliminate from top to bottom. So the top of my first fraction here, I'm going to factor out 5x. Leaves me with 3x plus 1. On the bottom, this one's interesting because it has a cube for my lead term. These trinomials that we factor have a squared term in the front, don't they? So look at all three of your terms in this trinomial. You can pull out an x, which then makes it look like something that we can factor further. So do that. Leave the x out there. Now we're going to have an x minus 3 and an x plus, no, we won't either. What are we going to have for that? Oops, sorry, that's what I did wrong. That was an 18. Sorry, guys. An x minus 3 plus 3. Let's just start that part again. Sorry, guys, back it up a little bit. Clean this up, too. I miswrote that number and it threw me all off. Here we go. There. That's how that bottom's going to factor. Okay? Second fraction. Let's go after that one. X. We have negative 15 back there, so if we go negative 5 and plus 3, we get the negative 15. We also get the negative 2x in the middle. Last one. First one has to go 3x and x. Then if I put a negative 3 here and a positive 1 here, I'm going to get that negative 8x in the middle. So look at your top and bottom stuff. 3x plus 1, 3x plus 1. I have an x plus 3 down here and an x plus 3 up here. I have a plain x on the top of this first one. And I have, oh, I forgot to rewrite that one, a plain x down here that would go. And I think that's all I can do. So what I'm left with on top is a 5. I'm going to circle what's left. We still have this 5, and we have this. On the bottom, we have this term and this term. So all of those make up our end answer. So all in all, we have a 5 times x minus 5 and x minus 6 times x minus 3. Okay? Next one. There's a lot of them. Hang in there with me. The next ones that we deal with, we're going to be doing more that look like fractions. So we just did one, so we've kind of reviewed how to multiply with them. But if you are going to add or subtract, okay, add or subtract, whoops, you need to have that common denominator. All right, so that goes with any fraction, common denominator to add or subtract. Number 2 is what we were just working with. You can cancel common factors from top and bottom when you multiply. If you have to divide, remember to flip the second one. You take the reciprocal of the second fraction and then it becomes a multiplication. Okay, that's what this next one is having us do. So let's take a look at a division. First, I'm going to do my reciprocal of my second one. So leave that and flip this. So the x squared plus 2x plus 1 is now the top. X squared plus x plus 1 is now the bottom. Okay, now we have multiplication. So maybe we can cancel some stuff. Let's do some factoring. Notice that the numerator on the first fraction is a difference of cubes. Try to remember your pattern. If you have to look back, go ahead and look back in your notes at the pattern to how to factor that difference of perfect cubes, but it's going to end up looking like that. The bottom of that one is difference of squares. That's an easier one to remember. So there's that one. The second fraction, the top is factorable. We're going to get an x plus 1 and another x plus 1 up there. The bottom, you can study that one for a little while, but that is not a trinomial that's going to factor. Okay, so we cannot get two factors that would FOIL back together to get us that expression. But take a look at that and take a look at the top of the other fraction that we had, and you're going to see that that's a cancelable piece because they both have x squared plus x plus 1 in them. So let's zap that part. So that's gone already. This is an x minus 1 and an x minus 1. We can even take an x plus 2 and an x plus 2. And there's only one thing left. X plus 1 is all we've got left. So it started out to be a lot, ended up with not much left. This one is a subtraction problem. So recall what we were just reviewing. You need to have a common denominator. Right now our denominators are not the same, so you are going to have to make them so they are. So this first fraction, you're going to have to multiply by x plus 2 over x plus 2. The second fraction, you're going to have to multiply by 2x minus 1 over 2x minus 1, because our common denominator is going to be 2x minus 1 times x plus 2. Okay, so the first fraction top ends up being this. The second fraction top ends up being this, and all of that will be over that common denominator. Okay, so now we begin to simplify some stuff. So simplifying that first part up there, we have x squared plus 2x. We have negative 1 times 2x, and negative 1 times negative 1. And then, oops, we still have the bottom. The top simplifies just a little bit. Okay, the 2x's are going to cancel. So we are left with x squared plus 1 over the denominator. And I think that's it. Okay. Next one. Oops, doesn't want to go. Here we go. Now, it's the same kind of thing here. We just have three fractions that we're putting together. So look at what your denominator is going to have to be. First of all, the middle one. That's a difference of squares. Factor it. Because now you can see that it does share part of the denominator of the final or the third fraction. All right, so think about what it is you're going to have to multiply by each fraction so that that term gets what it was missing on the bottom. Well, the first fraction has just an x. So it is missing the x minus 2 and the x plus 2. So that's what you have to multiply that first 4 by. It needs to be multiplied by both of these parts. The middle one has the x minus 2 and the x plus 2, but it needs an x. The last one has the x plus 2, but it does not have the x or the x minus 2. Okay, so let's start doing some simplifying. 4 times x minus 2, x plus 2, minus x plus 5 times x plus 4 times x minus 2 all over that huge big denominator, which isn't actually so bad. Okay, so now we got a lot of number crunching to do. First of all, I'm going to multiply these two back together, x squared minus 4. Now multiply that or distribute the 4 to them. So 4x squared minus 16. I'm going to multiply these two back together. We have x squared plus 5x. But now I'm subtracting both of them, so I end up with a negative x squared minus 5x when I'm simplifying. This one, we have 4x distributed to x minus 2. So I have a positive 4x squared, then minus 8x. All over x minus 2, x plus 2. All right, so obviously there's going to be some simplifying we can do up on the top. Okay, all of your x squared terms can go together. So we had 4, negative 1, 4. So that's going to be 7x squared. Then we have these two that both have regular x's, negative 5 and negative 8 make negative 13x. And we had just the one constant, so negative 16 over our denominator, and we're done. Okay? Complex fractions. You haven't worked with these for a while, but a complex fraction, vocab word for you, it's going to have fractions in both the numerator and denominator. So it kind of looks like a real mess. But you still have to take it in pieces. You're going to look at the numerator and you're going to put those two pieces together first. You're going to look at the denominator and then you're going to put those two pieces together. Okay, so on top, you have a 1 over x plus 2 and technically a 1 over 1, and you need to add them together. So my second number, my 1 over 1, I need to have x plus 2 for a denominator, so I have to multiply that whole thing by x plus 2 over x plus 2. So my top is going to be a 1 plus 1 times x plus 2, and that will all be over x plus 2. Now the bottom fraction, we have to do the similar thing. We need a 3 as the denominator for both pieces, so my second part is going to get multiplied by 3 over 3. So I have x minus 3 over 3. Now, take a look at that. You've got a division of fractions now. How do we divide with our fractions? Well, you need the reciprocal of the second one, and then it's a multiplication. So let's write down the first one first. Well, let's simplify. Okay, you had a 1 and a positive 2 up there. So is everybody okay with me just writing x plus 3 over x plus 2? Okay, see where that came from? I just put those two numbers together. And we're going to multiply then by the reciprocal, 3 over x minus 3. Okay, so we have a 3 and an x plus 3 on top. We have an x plus 2 and an x minus 3 on the bottom. And that's it for that one. Now we're getting into some funkier ones. We have negative exponents going on here, and that's okay. We're still going to try to keep in mind our rules of exponents, our rules of factoring out, And we should be able to hopefully pull something out of these that will allow us to simplify something out of these. Now, when you look at this whole thing, can everybody see this common thing? We've got x minus 1's in parentheses on both the front half and the back half. Okay, let me get my lines back out of there. I'm going to do sort of a factor by grouping type concept with that. And they suggest that we pull that out using the one, or factoring out the amount of the least exponent. Well, since negative 4/3 is smaller than negative 1/3, we're going to factor out, okay, try to follow with me here, x minus 1 to the negative 4/3 power. Now, remember, when you're factoring something out, you are dividing. And when we divide these terms together, we end up subtracting exponents. Okay, so if I divide this first term, the x minus 1 to the negative 1/3, I am actually combining it and subtracting, because when we divide our exponents, we end up subtracting those powers. Okay? Then on my second half, if I pull out x minus 1 to the negative 4/3, all I'm left with is a minus x back there. Okay? So, up front, just rewrite. We're not worrying about him just yet. Take a look at what those exponents end up doing. We have a negative 1/3, and remember what happens when you have minus a minus. It turns into, do that with another color, it turns into plus. So what's negative 1/3 plus 4/3? We end up with x minus 1 to the 3/3. Well, 3/3 is just 1. So that's just an x minus 1. Okay, now look in the parenthesis, we have x minus 1 minus x. So do you see how the x's are going to even cancel away? So simplify a little bit more. Hang on to this guy yet. We'll deal with this guy in a second. We are actually down to negative 1 for a total inside that parenthesis. Okay, now let's come back and deal with that last guy. Got a negative exponent. How do I get rid of it being negative? I need to take that term and put it to the bottom. So leave your negative 1, but the x minus 1 to the 4/3 now goes into the bottom. And that is your answer. Okay, so that was a little bit odd to look at, and it's that factoring out of something weird that makes it odd. But again, we were just putting to work our rules of exponents. Okay, this is the last one, I promise. I know this video is getting to be a long one, you guys. Hang with me. What can we pull out of both of these terms this time? Okay, so you guys see how they both have an x squared minus 2 in them? The smallest or the least power is that negative 1/2, so that's what we're going to take. So x squared minus 2 to the negative 1/2. What does it leave behind? Well, in the first one, it leaves behind just that x squared that was in front of it. Okay, remember, if we're pulling out x squared minus 2 to the negative 1/2, we are dividing it out, which means you're going to take 1/2 minus that minus 1/2 that you're pulling out, which turns into 1/2 plus 1/2, or 1. Okay, haven't done anything with the denominator yet, so we still have it. Now, take a look at inside the bracket. There's a little bit that we can reduce. So leave the x squared minus 2 thing alone for a sec. Inside the bracket, the x squareds can go together and make 2x squared. There's only the one constant, so it's still alone. And then we still have the bottom. Haven't done anything with that. Okay, now, the last thing that we need to get rid of is that negative power on the top. So it has to go down below. So leave the 2x squared minus 2 that was in the bracket. It's staying put. The x squared minus 2 from the top comes to the bottom now, and it has a positive 1/2. And we already had an x squared minus 2 to the positive 1 power down there. Those match, so we're going to put them together. When you put together exponential expressions that have the same base, you add the exponents. So what's 1/2 plus 1? Is 3/2. So your end answer should look like this. Okay. The book even went so far as to take that top and factor a 2 out of it and end up with x squared minus 1. So let's just take a look at what that does. If we're factoring completely, I suppose we better make sure we do this too. Now, what do you see in your numerator? What do we need to do with that x squared minus 1? Yup, that breaks more. Difference of squares. About running out of room on this problem. But that's the end-to-end. Okay? Alright, this is the part I like, or I don't like about this kind of problem. Your end answer is ugly. And a lot of times we will talk ourselves out of the correct answer because it looks something like that. So what I need you to do is really understand those rules of powers. And I don't know how much of this factoring out of that kind of exponential expression you've done before. I haven't done it for forever either. We got to make sure that we have enough discussion that you feel comfortable knowing what you're doing on them. Because, you know, not everything is going to turn out looking beautiful, but that doesn't mean that it's wrong. All right, there was one more example, and I did not put one on the slide because it was another one dealing with rationalizing a numerator. So you can go ahead, please look at the example number 11 that's in the book, but there will be so few cases again where we have to rationalize a numerator. We always end up rationalizing denominators instead, so I guess I could have took you through the process for the practice, but I decided not to. This one was long enough. So here's your assignment. Pages 48 through 50, 6 to 81 every third again. So half of them will be odd, half of them will be even. Please utilize that LarsonPrecalc.com website. It has worked out, talked out answers for the odds. You may find that very helpful for you. If you can't find that and you've been trying to find that site, please ask me in class because I think that's really a nice feature for you guys to have at home when I'm not there with you. All right, see you in class.